Kind of an interesting effect there, isn't it? That water and sodium may not be able to travel across the wall of this Henle at every single point. So it regulates how much water and how much sodium gets back into the bloodstream.
I guess it helps to move it through quicker, because if it were stopping it there, it would be harder for it to go back and ascend.
Yeah, because you've got, if you had a ton of water, it'd be hard to get it back up, you're right. Yeah. So, lupus Henle, bottom line you want to know is it can reabsorb sodium and water depending on which limb you're traveling through.
So the ascending limb reabsorbs the solute?
Just solutes, right. Yeah, ascending is just solute. So we've done a good job taking a lot of things out of our blood, or out of our filtrate, returning it to the bloodstream. And by this point, we may be done. If you have, blood pressure that's currently normal at homeostasis, if your blood sugar is currently normal and your sodium and water levels are as your body would need, then we may be done with the process, and whatever remains now in these tubes, traveling through the DCT and over here to the collecting duct, may eventually form urine. So we may actually be done with the process if you are at this awesome, wonderful homeostasis, but of course that's probably not the case. So let's flip on over to page 116 and talk about the DCT. And this information starts on page 852. How about questions so far? Okay, so where is filtration occurring? Glomerulus, good. What types of items are reabsorbed with sodium at the PCT?
Water.
Water and glucose, chlorine, bicarbonate. What item is reabsorbed rather at the PCT that does not have to be coupled with sodium? Amino acids, good. So we've got a number of items that are coupled with sodium, but amino acids do not have to be coupled with sodium. The reabsorption that occurs at your PCT, is it driven mostly by just automatic reabsorption, or is it driven by hormones? Automatic. Just automatically take in a large number of our water and sodium, so there's no hormones necessary at the PCT. What types of items are removed by your lupus Henle? Sodium and water. Yeah, so we're taking more sodium, more water back out. So now by the time we reach the DCT, this gets to be serious business, because now we're looking at this being hormone driven. Okay, so on page 116 of your course pack, we are still performing reabsorption here. Let's first do sodium. Okay. Alright, now you're going to notice with the DCT, sodium is only reabsorbed if you need it. How do you get it back into the bloodstream? You have to use aldosterone. So here's the renin-angiotensin mechanism again. You might recall the JGA over there is responsible for increasing the pressure in the efferent arteriole by releasing a hormone called angiotensin II. You'll notice that on your worksheet that angiotensin helps to maintain high enough blood pressure so that we can still form filtrate. But you'll also notice the last little point there under mechanism for sodium. You see where it says that angiotensin also promotes the release of aldosterone. Okay, so if you have low blood pressure, we can still maintain filtration simply due to angiotensin II, but we may need to get more sodium and water in the bloodstream. So angiotensin leads to the formation of aldosterone. Aldosterone is going to target your DCT. Okay, so now we have reached the point where we've taken back all the sodium we normally would reabsorb, but we perhaps need extra because our blood pressure is currently too low. So aldosterone implants sodium channels in these tubes Those sodium channels allow for sodium to travel from the tube into the bloodstream. If sodium channels are present, you reabsorb sodium. If sodium channels are not present, where does the sodium go?
Out.
Bye-bye, all right, leave it in the urine, let it go. So as long as aldosterone is present here at the DCT, it inserts sodium channels so you can reabsorb more sodium into the bloodstream, and that does ultimately what for your blood pressure? Increases it. So we have a long-term fix here for your blood pressure by inserting those sodium channels. We also have a real quick fix here with angiotensin II. What's the relationship between angiotensin II and aldosterone? Good. Yeah. Angiotensin II actually stimulates the production of aldosterone, so it's a tag team effect here to make sure that you have blood pressure high enough to be able to operate and form filtrate. I want you to notice a couple of things here that inhibit those aldosterone sodium channels from actually working. Caffeine is kind of an interesting one here because it keeps the sodium in your filtrate. Caffeine inhibits aldosterone's job of inserting those sodium channels. So instead of reclaiming the sodium back into the bloodstream, the sodium leaves in your urine. Ultimately, what does that mean is going to happen to your blood pressure? Decreases. Yes, if you lose those sodium channels, then of course you lose some sodium to the filtrate. It just continues on traveling through DCT. It travels out through the collecting tube and then it leaves in the urine. So in a way, caffeine actually inhibits sodium reabsorption, and that can lead to lower blood pressure.
Wow.
Weird, right?
That sounds opposite.
It does.
Makes your heart beat faster.
Hyperactive, yeah.
It's a stimulant, but it's also stopping sodium from coming back in.
Wow.
Probably not enough to make you feel like you're going to pass out, but just
diuretic.
yeah. Unless you have like certain kinds of really high caffeinated drinks, yeah. Notice that Lasix we had talked about way back earlier in the semester. Lasix essentially does the same thing as caffeine. It stops aldosterone from inserting its sodium channels. So Lasix actually keeps you from absorbing more sodium to maintain blood pressure. So this is how things like Lasix are used to treat high blood pressure issues. You simply urinate away that sodium, and along with it you take any water that would have been coupled during reabsorption. So, you know, again, you've got Lasix and caffeine that both interfere with sodium channel ions, or ion channels there. So we essentially lose our sodium and any water that would have been coupled through reabsorption out in our urine. So, hey, if you lose blood volume, what does that do to blood pressure? Lowers it, yeah, decreases blood pressure. So actually Lasix and caffeine both lower the amount of sodium we take back in. Less sodium, less water, less blood volume, lower blood pressure in the long run.
So if you got high blood pressure, just drink a bunch of Diet Cokes.
Yeah, or some Red Bull or whatever's got the...
There's a lot of sodium in Diet Coke. Just a lot of sodium. More sodium in a Diet Coke than it is.
So you'd have to have something that's really caffeinated to counteract that sodium. Crazy. I know. Let's talk about water, and Julie.
What else do we need to understand about the renin and angiotensin?
Two things. What does angiotensin do to your efferent arteriole? And then what does aldosterone do to your DCT?
But we don't need to know
The conversion mechanism.
how it works, or where it comes from, or
You'll want to know that it comes from the JGA if blood pressure is low.
to that, right?
To that, yeah. But as far as the conversion mechanism, I'm not going to test you on that, no. I would know that angiotensin leads to aldosterone production, but the cascading effect of changes to get there, I wouldn't worry about those details. DCT is reabsorption, but it's home to what we call facultative reabsorption for water. So here you can notice on page 160,